Here's the answers to the quiz over the second half of Chapter 6. Okay, problem number 1, it's asking us to evaluate the logarithmic expression without using a calculator. So how we'll do that is we're going to say, okay, what's 2 to what power equals to 16? So the answer to that would be 4. Okay, the next one is a little bit harder. 5 to what power equals 0.04? Well, let's figure out what 0.04 is. So 0.04 is 1 over 25. So this question is really asking log base 5 of 1 over what's 1 over 25. So 5 to what power is equal to 1 over 25. Well, the 5 has to go from the numerator to the denominator, so it's going to have a negative on it. And from 5 to go to 25, it's going to be squared, so my answer is a negative 2. Next one is log base 9 of 3, so 9 to what power equals 3, so the 9 would actually have to have a square root, so that would be to the 1/2 power. 9 to what power equals 3, so that would be 1/2. Okay, the next question is to graph this logarithm. So the first thing we're going to do is get the parent function. So the parent function is going to be the log base 3 of x. We're going to take off any shifts. And let's remember, when we do a logarithm, what we do is we pick a value for y to get x. So I'm going to pick a negative 1, 0, and let's pick 1. And so what we have here is 3 to the negative 1, that would be 1/3. Then 3 to the 0 is 1. 3 to the 1 is 3. Now that I'm going to shift those, so when we look at the original equation, we can see there is no shift or anything happening to the x, but the y is going to have a k value of 2, so the y value will change by 2. So this would be 1/3. Negative 1 plus 2 would be 1. Then I've got 1 and 0 plus 2 is 2. 3 and 1 plus 2 is 3. The domain, well, let's do the asymptote first. The asymptote is going to be related to the x value, and there is no shift on the x, so the asymptote is going to be at x equal to 0. Let's go ahead and put that on the graph. The domain would be x greater than 0, and the range is y is equal to all reals, and you can put those in interval notation. So let's go ahead and plot the points. I've got 1/3, 1. Then I've got 1, 2. Then I've got 3, 3. And so this is going to come along the asymptote and swing out. Okay, let's go ahead and do the next one. What we have here is y is equal to the log base 3 of x minus 2. So if we look at that, h is going to be equal to 2, right, because it's x minus h, so h is equal to 2, k is equal to 0. So doing my parent graph, which would be log, let me make sure it was log base 3. The next one is log base 3, yes. Okay, it's another log base 3. So what we would have is, let's pick the same points. We'll pick a negative 1, 0, and 1. So the parent should be the same. 3 to the negative 1 is 1/3. 3 to the 0 is 1, and 3 to the first is 3. And now let's shift it. So what's going to happen is we can see that h is a negative, h is 2, so my x is going to increase by 2. So x plus 2, and the y won't change. So 1/3, I would have 2 and 1/3. 1 I would have 3, 3 would have 5. The y value would be negative 1, 0, and 1. They didn't change. The asymptote's going to move to my h value because it's a logarithm, so the asymptote is going to be x is equal to 2. the domain would be x greater than 2, and the range would be y is equal to all real numbers. Let's go ahead and put the asymptote on the graph. So the asymptote here is at x equal to 2. Let's plot the points. 2 and 1/3, negative 1. Then I have 3, 0. Then I have 5, 1, 2, 3, 4, 5, 1. The graph's going to come along the asymptote, like that. Okay, let's go to the next problem. Okay, the next problem is asking me to use the property of logarithms. So we're going to have to expand and condense these logarithms. To do that, that's what it's asking. So I have two numbers multiplied together inside of a logarithm. So those are going to be adding logarithms. So I have log base 4 of 16 plus log base 4 of 4. Okay, so evaluating the first logarithm, 4 to what power gives me 16? Well, that would be 2. 4 to what power gives me 4? That would be 1. So 2 plus 1 would be equal to 3. Okay, moving to number 7, I have inside the logarithm, I have a division. So I'm going to subtract the logarithm. So I have log base 3 of 1 minus log base 3 of 3. So log base 3 of 1, that would be 0. 3 to what power gives me 1? 3 to what power gives me 3? That would be 1. So 0 minus 1, that'd be a negative 1. Okay, the next question asks me to expand these logarithms. So what that would be is I'm going to, actually I'll take 2 steps on this. So I have a multiplication problem here. If I would have anything that's a denominator, I would subtract the logarithms. For all things that would be in the denominator, they subtract. These are both numerators, so they'll have plus signs in front of them. So I'll have log base 5 of x to the 1/3 plus log base 5 of y to the 6. Now we'll take those exponents and we'll move those to in front of the logarithm. So anytime there's an exponent, it multiplies by the logarithm. So I've got 1/3 log base 5 of x plus 6, that's the exponent on the y, log base 5 of y. The next one asks me to condense them. So I have 3 logarithms, 2 are added and 1 is subtracted. So let's go ahead and first thing to do is let's bring the exponents in. Anything that's multiplied in front of the log will be an exponent. So I'm going to take the first one, which is 3 log base 3 of 15, and change that to log base 3 of 15 cubed. And that would be plus log base 3 of x squared. The 2 would move to the exponent. And then minus log base 3 of 25. Okay, now let's condense that part. So the 2 that have plus signs in front of it, that would have a plus, are going to be numerators. So I have log base 3 of 15 cubed x squared. And then the subtraction one would be on the bottom. Okay, now on a test, I would let you leave it the answer like this, but if we want to go ahead and simplify this, we could simplify the numbers. So if I take 15 cubed, which would be a number, then divide that by 25, I'm actually going to get 135. So that's the most simplified answer, but of course on a test, like I said, I'd probably let you leave it in exponential form like that. Okay, the next one says, use the change of base formula to evaluate the expression. So I can change this into both either an ln or a base 10 log, whatever I choose, because those are the keys on my calculator. So I could evaluate it like this, the ln of 23 all over the ln of 5, or I could evaluate it like this, log of 23 over log 5. Okay, so either way, what I'm going to get, let me put that in the calculator. Okay, and what I got when I entered those in the calculator would be 1.948. Okay, the next four problems are solving both exponential and logarithm problems. So the first thing we need to do is always isolate the part that is either the logarithm or the exponent. So I'm going to isolate this e to the x. So I'm going to add 2 to both sides. That gives me 4 e to the x is equal to 16. Now I'm going to divide by the 4. So I've got e to the x is equal to 4. The variable that I want, x, to get x is equal to is trapped in an exponent position, so I'm going to change it to a logarithm to get it out of there. So this is a base e, so that would be ln. The 4 moves into the logarithm and the x is on the outside, so I'm going to have to evaluate the ln of 4, which is 1.39. So 1.39 is equal to x. The next one, once again, we have to isolate the log or the exponent, so I'm going to isolate that. So I'm going to get log base 2 of x is equal to 24 over 5. Okay, let's change it to an exponential. So I will get x, or 2 to the 24 fifths is equal to x. So I'm going to put that in the calculator. That would look something like this. 2 caret, and now you have to enclose in the parentheses the 24 divided by 5, or you're going to get a wrong answer. Now I got 27.858. Okay, the next problem, it's a logarithm equals a logarithm. Note there are no numbers or anything added to either side, so this is an easy one. If the logarithm have the same base and there's nothing added or subtracted, then what's inside the logarithm must be equal. So that says 3x plus 1 must be equal to 2x minus 8. Let's subtract 2x from both sides. That would be x plus 1 is equal to a negative 8. And now then, let's subtract 1, so I've got x is equal to a negative 9. Okay, now we need to check the solutions, and I should have checked the solutions up here. Notice there's some decimal numbers, so if you plug those back into the value for x, you need to check that to see if that's true. And notice on this one that says log base 2 of x, if this would have been a negative number, that would have been an extraneous solution because you don't take the logarithm of a negative number or 0. So let's look down here, and what we can see is if we check this, then I'm going to have the natural base logarithm of 2 times a negative 9 plus 1 is equal to 2 times a negative 9 minus 8. And what you can see is that in both those cases, that this part here, that's going to be ln of a negative 18 plus 1, which would be the logarithm of a negative 17, and I'm taking the logarithm of a negative number. So that's not going to be a good solution. So the only solution that I got, x is equal to a negative 9, doesn't work because it gives me a negative, taking the logarithm of a negative number. So that would be extraneous, and this particular problem would have no solution. Okay, let's move on to the next problem, and what I have is a logarithm equals a logarithm plus a number. So what I want to do is I'm actually going to want to combine these two logarithms into one logarithm. So let's go ahead and I'm going to add log of x minus 1 to both sides so that I can move the logarithm over. And what I'm going to get is I'm going to get logarithm of x plus 1 plus now the log of x plus 2 is equal to 1. These two logarithms are going to combine. They are added, so when I combine them inside one logarithm, they will be multiplied together. So basically I'll have something that looks like this. Okay, so we'll need to multiply these together by the formal method. So I'm going to get the logarithm of x squared plus 3x plus 2 is equal to 1. Now this is a base 10 log, so remember that now we're going to go ahead and change it to an exponential to get what's inside the logarithm freed up. So that would be 10 to the first is equal to x squared plus 3x plus 2. Now I'm going to subtract the 10 from both sides so that this is equal to 0. That's how we solve a quadratic. I get x squared plus 3x, and if I subtract 10, I'm going to get a minus 8 equal to 0. Oh, I already set that equal to 0. Hold on a second, I made a mistake here. Can you see that when I miscopied this one piece down? It should be the logarithm of x minus 1, and in here I've got x plus 1. So I'm going to go ahead and change those. Okay, so what this is going to be is when I bring this over, I'm going to end up with the logarithm. Remember, those would add, so I would have the logarithm of x plus 2 times x minus 1, when they combine, would be equal to 1. So log of x squared plus x minus 2 is equal to 1. So let's go ahead and convert this to an exponential. So that would be 10 to the first is equal to x squared plus x minus 2. Setting the quadratic equal to 0 means I'm going to move the 10 over to the other side. I would have 0 is equal to x squared plus x minus 2, and then this 10 would subtract 2, so that'd be a minus 12. And solving the quadratic into factored form, I would have x plus 4, x minus 3 equal to 0. So the potential solutions would be x is equal to a negative 4 and x is equal to 3. Now we're going to have to check those. So if I'm going to look at a negative 4, you can already see that if I put a negative 4 into my original equation, I'm going to end up with a negative logarithm at the x plus 2 over here, and also at the x minus 5. So I already can look at that and see that those would be extraneous. And then the 3, let's check it. Okay, so I'm going to get the logarithm of 5 is equal to a negative logarithm Okay, to save time, I went ahead and plugged these numbers in. So if we set up the check, I would have the logarithm base 10 of 5 is equal to a minus the logarithm, and I'm going to put a 3 in to the original equation, right? That would be 3 minus 1 is 2 plus 1. So if I go ahead and then evaluate those on the calculator, I get 0.698 is equal to 0.698. So that checks. So that would be a solution. 3 would be good. The next question says that I'm going to deposit $1,000 in an account at 5% interest, compounded continuously. How long would it take my money to double? Okay, so what I have is I have the equation is the amount I have at the end is equal to the amount invested, E to the RT. Now I deposit $1,000 in an account, so that would be A is equal to 1,000 e to the RT. And of course, the A would be 2,000 to be doubling, right? But actually, if you can see, I didn't really even need to know the amounts. Because if I know that it doubles, the first thing I'm going to do over here is divide both sides by this 1,000 to get e to the RT all alone. And that's going to leave me with 2. So if it would not even have told me what the amount that I deposited was, but it said how long will it take your money to double or triple, the fact that the first step would be to divide by the amount that I started with, all I really need to know is if it triples or doubles. Note that if it said it had grown by 5 times, I would simply have this equation to use. Okay, so that's something to know that you may need to know for a test. Anyway, let's go ahead and solve this. So what I have is I have 2 is equal to E, and my interest rate is 5%. That's 0.05 to the T. And I want to get the T out of there, out of the exponential. So this would be a log. I'm going to change it to a logarithm. So I have ln. The 2 moves inside the log. And on the outside, I would have what's in the exponent here. So that would be 0.05 t. So the ln of 2 is equal to 0.693. Now I'm going to divide both sides by 0.5. 0.05. And what I would get is if I divide both sides by 0.05, I get 13.86 is equal to t. So t would be equal to 13.9 years.